Hello everyone and welcome to another SunCat Byte. Today's SunCat Byte will talk about operators and more specifically the insertion and extraction operators which are used for input and output, and also arithmetic operators which are used for arithmetic or math. So first off, an operator is just a symbol that represents certain instructions or commands in C++. Simple example, or a simple addition example, has a few operators in it. So if we look at this line of code, we have a number of operators in here. First of those operators is the equal sign. That's the assignment operator. And we also have the star there, which is the we'll do it this way, which is the multiplication operator, and the plus, which is the addition operator, and the one that I left out here, slash, forward slash, which is the division operator. Okay, so that's a simple example, operators. We also have, and I don't think we've seen to this point, maybe not CIN, but we have seen COUT statements. So we have two other operators that are seen in conjunction with the CIN and a COUT statement. CIN look like this, COUT look like that. So this operator here, the greater than, is known as our extraction operator. We're extracting input from the user. COUT is our insertion operator. We're inserting output, in this case, during this semester, to the console, or our console applications. Okay, so what happens is when the program runs, it sees this CIN statement, and it stops when it reaches it, and then it waits for data. So the user has to type the data in, and then they hit the enter key, and it actually gets the data they typed in. Okay, so if we have this example, here, we're asking the user to enter the average speed. Here, this character is going to be a new line character, so it's going to give us basically a blank line and then that information. Then we say CIN speed. So here we have the insertion operator inserting that output to the console, and then CIN, the extraction operator, extracting whatever the user types in and putting it in the variable speed. Similarly, if we then say please enter your name, CIN name, same thing. Asking the user for their name here by using the insertion operator, then extraction operator to extract that data. Okay. The other thing we can do is we could use multiple extraction operators to get different pieces of data at one time. So say we had something like this. Similarly, we also have multiple insertion operators, right? Here and here. So we'll just keep flowing with the data. And remember that this format is okay because of the white space tolerance in C++. What this is going to do is it's going to tell the user, enter the number of days you're driving on one line. Then the next line, it's going to say the speed and hours driven each day. Then on the next line, it's going to say such as 4, 68.0, and 7.5. So it gives the user an example of what they can enter. Then if we want to get all that data, one after the other, we can do this. Okay, so what that's going to do is the user's going to enter days on road. They're going to put an integer in for days on road, and maybe 4, for instance, if we say above, and then they're going to hit enter. So days on road is going to get the value of 4. Then they're going to say 68.0 and then hit enter. So 68.0 speed is going to get the value of 68.0. Then they're going to say hours each day, 7.5 hours each day. They hit enter. Hours each day gets the value of 7.5. All right, so that's how our insertion and extraction operators work in conjunction with cin and cout. Cin is to input data, cout is for output to the screen. Okay, so now we want to talk about another operator, which is the equal sign operator that we alluded to above, the assignment operator. So the assignment operator works by taking everything that's on the right and assigning it to the variable on the left. So you have this expression here. The result of this expression gets assigned, that's why it's called the assignment operator, to the variable on the left. Okay? So the assignment operator, the value on the right side of the equal sign and places it in the variable on the left side. For instance, if we just wanted to say balance equals 153.4.25, oops, like this, we can do that. We can say number of pipes, and pipes equals 8. Right, so it's taking this takes this value, assigns it here. This takes this value, assigns it here. We can even use 2 variable names. We can say x equals y. What that's going to do is whatever the value is of the variable x, it will now assign it to y. Okay? So a concept to think about when we're assigning variables is they have a space in memory. Okay, so when we say we have balance, let's do this. Let's say we have a variable called, let's go down here, int test. As soon as I make this statement int test, I get a variable in memory. It's test. It has no value at this point. If I then make an assignment and say test equals 0, I now get that value here. Test is 0. I overwrite it. If I come in and I see another line of code and it says test equals 4, this comes here, it overwrites what was there. Now I get 4, not 0 anymore. So I say int test2 equals int test2 equals 5. If I do that, I now have test2 in memory. It has a value of 5 because I initialized it. I then come in and say test2 equals test. That means test 2 is going to get the value, whatever the value of test is. Here's test 2, the value of test is 4, so this now gets overwritten with 4. So as I work through programs, and you'll see this throughout the semester, you guys will actually have a group project later in the semester where you do this kind of thing. I like to use Excel or just a piece of paper and actually keep track of my variables on the side to go ahead and show me how variables are changing and make sure that I understand the flow of the program, understand what's going on. So this is a good tool. I suggest you guys use this on your own, and some of the examples that we go over in the book are from the book, the sample code. Okay. So now, with our arithmetic operators, we also have an order of operations, just like you would have in regular math, right? This table summarizes that order of operations. So we have our primary operators, which are basically these things here, the open and close brace, square brackets, dot, and the arrow. The one thing that we're going to use right now out of this whole list is just going to be the open and close bracket, and it's going to be to, just like you would do in math, to organize things and do what's inside of the brackets first. Then we have arithmetic or arithmetic, so we have star, slash, and a percent symbol. The star and the slash. Star is multiplications. Forward slash is division. The percent symbol is a mod called modulus, our mod operator. We're going to talk about that here in a bit. That's different. That's going to be something new for most of you. And then addition and subtraction, and then finally assignment. So associativity left to right, right to left. This right to left is because things get assigned into that variable on the left from the right, right? So it's right to left. Okay. So straightforward there. Say we do a divide in C++ of an integer. We say 9 divided by 5. What that's going to do, keep in mind that these are integers. It's going to just give us how many times, the number of times 9 goes into 5 whole. So it's going to just return a 1. We don't have a decimal or anything like that because it's integer math, 9 divided by 5. If I take and mod 5, that's going to give me the remainder. So 5 goes into 9 one time, right? And we have a remainder of 4. So for the mod operator, we get 4. Another thing to keep in mind is that mod or modulus only works with integers. It will not work with decimals, in our case, which are double or floats or anything like that. It only works with integers, okay? So that's the short of the mod operator. So now, let's say we have this. We want to look at order of operations. A equals B times C plus D times F. So what's going to happen here? In what order? What's going to happen first? B times C, because our multiplication is first, right? And it's left to right associativity. So B times C is first. Then, after we have that result, what's next? The other multiplication, B times F. Then, after that's finished, what's next? The addition, right? So it's the result, basically, of the two. So addition is last. Actually, not last, addition is third, and then last is going to be the assignment. So we have B plus C that's done first, then D plus F, then the results of those gets added there, and then we have it assigned here. Okay, so we look at another example. Here we have this, M equals, here we have parentheses. This. So what's going to happen first? The parentheses happen first, right? We actually have s plus t first because they're in parentheses. Then what happens? Well, then that other addition isn't inside parentheses, so then we're going to have left to right associativity, and we do the r divided by p. That's second. Now that that's done, we have that multiplication to do. So times q, basically, right? And then finally, we have the assignment done again. So we have equal, which is the assignment. Okay? So that's how that works. Next thing we want to look at is the variable and the type of variable. So say we have ints and we have doubles, for instance. So if I say double x equals 15 with a double, so it has a decimal value. If that's the case, this will actually store 15 point, let me get the right number of decimals here. 15.00000, okay? If that's an int, say we have int money equals 345.22. That's going to actually store just 345. The reason for this being is it's an integer. Integer does not have the decimal value, so it does what's called truncates. So it truncates to 0.22 and just leaves us with 345. So that is truncated. It's gone. It doesn't get rounded. It just leaves us with 345. This gets truncated. It gets cut off. All right. Say we had some other ways to represent 5. We have it this way. We have it this way. We have it this way. Like that. Or even like that. Okay. If we do it this way, that's an integer. Here, it's going to be a double. Here, also a double. This, because it's in these single quotes, is a character or a char. Here, because it's in double quotes, is a string. So these top three are actually numbers. That's a character, that's a string. All right. Things to keep in mind is that variables don't have a value automatically. You have to assign the value to the variables. Don't assume that there's a 0 in there because there's not. Okay? So you have to typically initialize a variable. In many cases, if you don't, in various types of C++ development environments, you'll get the highest negative value possible by default. All right. So we talked about the modulus operator, how that worked, our different operators. So something else we want to talk about is, what if you have a double times a double, or an int times a double? What's the resulting value? So there's a few different ways to look at it, or a few different combinations we can have. Okay, and the operands are the different parts of the equation, right, or the expression. So if we have an int and an int, for instance, 4 times 3, 4 times 4, let's say 3. The result is an int. Okay, pretty easy. If you have a float and an int, the result is a double. If you have a double and an int, your result is a double. If you have float and a float, result is a double. If you have a double and a double, your result is a double. What if you have a float and a double, or vice versa, double and a float? You can probably guess. You have a double. An integer and a double. Actually, that's it. We already got the rest. So that's basically the end of that. Keep this in mind. It will come into play when you're writing your programs. So I always like to look at this table that's also in your book when we're looking at this at arithmetic. Keep in mind, here's algebra, here's C++ the right way, here's C++ the wrong way. What this basically amounts to is you don't do things exactly the same as you would in algebra. Just because something looks away in algebra doesn't look that way in C++. So if we look at this first equation here, V equals A plus B times C minus D. If you just do a straight translation of that in C++, it's not going to work. The reason being is there's no implied multiplication between these parentheses here. So you have to write it as V equals A plus B times C minus D. That's the correct way to do it in C++. If you do it this way, it will not work. So say we have another equation, surface area equals pi times radius squared. Two ways to do that in C++ actually. You can just say surface area equals pi times radius. So rad, right? Or this is a function that we can use to say radius to the second power. Either of these works. Again, if you try to do it this other way, with the implied multiplication by parentheses, it will not work. And also, you can't say pi times radius times 2. Or caret 2. So there's no caret 2 to raise to the power. There's no time times 2 to raise to the second power. There's no time times 2 to raise to the second power. A equals C plus B times x minus y, or divided by x minus y. So you need to use the parentheses here, like we do on C plus B, divided by x minus y. If you don't use the parentheses, you're not going to get that math done correctly. And you can look at the last couple examples here. These ones are just using a square root function here. And notice the square root has parentheses inside of this in the arguments. And here we have a sine function. So there's not a one-to-one translation from algebra to C++. So you got to keep that in mind and understand how things actually work in C++. All right. So now that we've covered these, we also have a couple of other kind of shortcut operators called the increment and decrement operators. Increment operator is simply plus plus. Decrement operator is minus minus. And you use them in conjunction with variable names. So if you say I plus plus, that's going to take whatever was in I and increment it by 1. If you say I minus minus, that's going to take it and decrement it by 1. So this I plus plus is the same as saying I equals I plus 1. This I minus minus is the same as I equals I minus 1. Okay? Some things to keep in mind. If you're simply adding, these statements are the same. So if you don't care the order, the way that things happen. If you're not, I'm sorry, not these statements, this statement. We can also do minus minus plus plus I and minus minus I. So if you're simply adding, these statements are the same. If you're simply subtracting, this statement and this statement are the same. But if you're not, then there's a difference. These ones are called prefix operators. These ones are called postfix operators. So the prefix and postfix operators do things in a different way. The prefix operator will increment or decrement and then assign. Postfix operator will assign and then increment or decrement. To look at this, we can look at the following table. So say we have this case. We have m equals plus plus I. So let's go back to our spreadsheet and look at things in memory and keep track of things. So we have two variables in this case. We have m and we have I. Okay? So here's m, here's I. So as you see at the top, it says I equals 5. We start with I equals 5. So at this point, I has 5. Okay, so if we say m equals plus plus I, that means we're going to increment first. So that's the same as I equals I plus 1, right? So this plus plus I means that we increment first. So I gets incremented first. So now I gets 6. Then we assign. Then we say m equals I. So then 6 gets, I'm sorry, m gets 6. Okay, so in that first case, when you're done, you have I equals 6, m equals 6. Now let's look at the next case. Again, we start with I equals 5. We don't have anything in m. So now we say m equals I plus plus. Remember, if you do this, then it's assigned first. So m gets the value of I, so m gets 5. Then we increment I. I equals I plus 1. I gets 6. Now you're left with m equals 5 and I is 6, as you see here. Now look at our next case. Again, we're going to start with I equals 5. We're going to say m equals minus minus I. This means we decrement first. So I gets decremented. I gets 4. Then we assign. So m gets what? The value of I, which is 4. So now we're left with 4 and 4. Last case. Again, start with 5. The assignment is done first, so m gets the value of I, so it gets 5. Then we decrement I, which is 4. But as you can see, in that case, it does matter because things happen in a different order. All right, the last operators I want to talk to you guys about in this Suncat Byte are going to be our accumulation operators, which are really shortcut operators. And what those operators are going to be plus equal, minus equal, star equal, backslash equal. What these basically do, and these are called accumulation operators, and they're a shortcut. So say I want to do sum equals sum plus x. I can use an accumulation operator and just say sum plus equal x. For the same thing, it's just a shortcut. I can do the same thing with diff, say diff equals diff minus x, or diff minus equal x. The shortcuts, they're just a fancy way to kind of do that kind of math. So keep that in mind, and you can use that in your code. All right, so last thing I want to look at in this Suncat Byte is a couple of examples of things that we covered earlier. All right, so first thing I want to look at is this program 212, which is in our sample code on Blackboard. Okay, so, and it's looking at math and integer division. And so it's looking at math and division specifically. So let's go back, let's step through this program and use Excel again to keep track of what we think the variable value should be. Okay, so in here we have two variables. We have resInt and resDouble. Okay, so resInt, resDouble. They initially, when we run through this program, do not have a value, right? Nothing there, nothing there. Now we come in and we say resInt equals 16 divided by 3. So remember, this is integer division, right? But resInt is an int, resDouble is a double. So got to remember how it's going to be represented as well. This should be, what is it? So resInt is 16 divided by 3. 3 goes into 16 5 times without the remainder, right? So then that should get 5. resDouble should be is 16 divided by 3, but it's going to be a double value, so we should have 5 point a bunch of zeros, right? And in order to get that to show here, we need to format the cells to be decimals. Okay. Now, these here are going to be IO manip flags, which we will cover in another SunCat by, but what it's basically doing is these two lines here are saying I want to show the number of decimals after the number of units or number of digits you want to show after the decimal. I want to show them. That's what this says. Please do show them. And this one says show 14 of them. Okay. So now we're getting the output. Integer division is 16 divided by 3. So then we're going to get resInt and resDouble. So at this point, what we would expect to see would be 5 and 5.00000, right? That's that. Now, we're going to come further down. We're going to say resInt is equals 16.0 divided by 3.0. resDouble equals 16 divided by 3.0. So keep in mind, this is still an int, right? So that's still going to be 5. Now resDouble, 16 divided by 3.0, that's going to be a little bit different because now we have an integer divided by a double. And remember from earlier, an integer divided by a double will give us a double. So what's 16 divided by 3.0? Well, we're in Excel. We'll just let Excel do the math, right? 5 with a bunch of repeating 3s. So at this point, we should see 5 and 5.33333. Keep in mind these values actually overwrote these ones, right? So really, that should be there. And so we should have that now. All right, so let's go ahead and run this. See what we get. Compiled. Start without debugging. And there you go. We see exactly the results that we were thinking that we would see as we step through it with Excel. All right, so that's that. Let's look at our one more example. So here we have X, Y, Z, and Q. All right, so if we look at X, we've got 2 plus 5 plus 4 minus 6.0 times 7 divided by 2, right? Do order of operations here. What math are we going to do first? 5 times 4, right? So then we would basically have 2 plus 20.0, right, minus 6.0 times 7 divided by 2. Okay, so we did that math first. We did the multiplication first. 2 plus 20, we're left with 2 plus 20.0 minus 6.0 times 7 divided by 2. What math do we do next? We do the multiplication, just 6.0 times 7. That's going to give us 2 plus 20.0 minus 6 times 7, which is 42. 42.0 divided by 2. All right, so done. What do we have next? Make this bigger. There we go. We have division, right? So we have 42 divided by 2. So now we have 2 plus 20.0 minus 21.0, right? Because this here is an integer. I mean a double divided by an integer, so that's 21.0. Now 2 plus 20 is 22.0 minus 21.0. So we should be left with 1.0 there. Again, it needs to be a decimal. .0. Similarly, we can step through this one. I'm only going to do this one, and I encourage you to do Z and Q on your own after you look at this lecture. But so we have 2 plus 5.0 in parentheses times 4 minus 6.0 times 7 divided by 2 in parentheses. So parentheses first, left to right, we get 7.0, and then we have times 4 minus 6.0 times 7 divided by 2 parentheses, right? So we have the 7.0 there, 2 plus 5.0. Now we need to do the parentheses on the right. So we get 7.0 times 4, and then minus, and then the 6.0 times 7. 6.0 times 7, which is 42. And then that's going to be divided by 2. That's still in parentheses, so 21.0. All right? So 7.0 times 4 minus, and then 6 times 7, 42.0, divided by 2, 21.0. So now we have the other, actually we don't need this anymore, right? We have 7.0 times 4, which is 28.0, so 28.0 minus 21.0 should be, G here a little bit, 7.0. Okay, so down here on the bottom, basically what this is doing is just like in the other one, it's saying do 3 decimals of precision. This will help align things to set with. We'll cover that more in our IOmanip lecture. But let's go and build this solution. Start without debugging, and as you can see, the 1.00 and 7.00 were as we calculated here. As I said, I encourage you to look at Z and Q and also do that math to make sure that you understand the order of operations. That'll do it for this SunCat Byte. If you have any questions, comments, or concerns, please email me or ask a question on the discussion board or attend office hours or lab hours on Tuesday or Thursday. Appreciate your time, and I will talk to you soon.